So here's our roadmap for this whole journey. We've broken it down into 5 key stages. First, we'll talk about why we even do this. Then, we'll see how the fuel gets prepped. After that, we dive into the reactor. That's where the real magic happens. Then we'll learn how all the valuable stuff gets separated and recycled. And finally, we'll see how the finished product is made stable. Let's dive in.
All right, so let's kick things off with the big question. What's the fundamental goal here? Why do refineries build these massive, complicated, and expensive units? It really all comes down to one incredibly powerful chemical reaction.
The name itself gives you a pretty big clue: hydrotreating. It's all about treating fuel with hydrogen. But, it's not as simple as just mixing in some gas. It's this really precise recipe. You need the hydrogen, plus extreme heat, intense pressure, and a special material called a catalyst. You bring all those things together, and they kick off the chemical reactions that do one thing, and one thing only: purification.
So what are we actually cleaning out of the fuel? Well, these are the main bad guys. Sulfur is public enemy number 1. Getting rid of it, which is called desulfurization, is how we get ultra-low sulfur diesel, or ULSD. That's the stuff that modern laws demand to help get down on things like acid rain. But the process also yanks out nitrogen, oxygen, and a bunch of other unstable compounds that can junk up engines and create nasty emissions. It's basically a complete chemical makeover for the fuel.
Okay, so now we know why we do this. It's time for our fuel's journey to really begin. But before it can get to the heart of the unit, it has to be prepared. Meticulously prepared. This whole first stage is about getting the feed perfectly clean and heated up for the big transformation that's coming.
So the very first stop is the feed coalescer, and its job is simple, but it is absolutely critical. The slide nails it. Just think of a giant salad dressing separator. You know how oil and vinegar separate? Well, diesel and water don't mix either. And this big tank just gives any stray water a chance to settle out to the bottom, where it can be drained off. Because the one thing you definitely do not want going into a super hot reactor is water.
This slide lays out those first few steps perfectly. So after the coalescer gets the water out, the feed goes through some filters to catch any little solid bits. Then it hangs out in the feed surge drum, which is really just a holding tank that makes sure the flow stays nice and steady. And finally, these massive charge pumps kick in, and they start building up the insane pressure our fuel is going to need for the rest of its trip.
And right here, this is where the hydro and hydrotreating officially begins. The high-pressure diesel gets mixed with a stream of hot, high-pressure hydrogen gas. Now this whole mix needs to get even hotter, and this is where the design gets really smart. It flows through these things called heat exchangers that are right next to the pipes carrying the finished, super hot product that's leaving the reactor. So the outgoing hot stuff preheats the incoming cold stuff. It's a brilliant way to recycle a ton of energy.
Those heat exchangers do a lot of the heavy lifting. But to get that final blast of heat, the mix goes through the charge heater. It's pretty much what it sounds like: a gigantic, super precise furnace that brings the mix up to the perfect reaction temperature. We're talking hundreds and hundreds of degrees Celsius. Okay, our drop of fuel is finally ready for the main event.
So we've cleaned it, we've pressurized it, and we've heated it up. Now we are entering the heart of the hydrotreater, the reactor. This is where the actual transformation happens, all inside this massive, thick-walled steel vessel that's built to handle almost unimaginable heat and pressure.
Seriously, everything we've done so far, all that cleaning and pumping and heating, it was all in preparation for this one single piece of equipment. The reactor is usually this tall, vertical tower, and it's just packed with catalyst. It's inside this vessel that all those unwanted molecules finally get torn apart and rebuilt into the cleaner ones that we want. Now, here is a really crucial detail about the chemistry going on. The reactions inside are exothermic. And just like the slide says, that means they don't just need heat to work, they actively release a massive amount of their own heat. As those contaminants are stripped out of the fuel, the temperature inside that reactor just starts climbing all by itself. And managing this self-generated heat is one of the most critical parts of running this whole unit.
So what's actually going on inside this tower? It's definitely not just an empty tank. At the very top, an inlet diffuser spreads the flow out nice and even. Then, the fuel and hydrogen mix trickles down through several different layers or beds of catalysts. But remember that crazy exothermic heat? Well, in between each of these beds is something called a quench section. This is where cooler hydrogen gas is injected to soak up all that extra heat and get the temperature back down into the perfect range. This kind of precise temperature control is absolutely essential to keep the process efficient and safe.
All right, the chemical transformation is done. Our diesel is officially purified.
But the stuff coming out of the reactor is this hot, high-pressure soup of everything. You've got the clean fuel, leftover hydrogen, and all those nasty contaminants we just stripped out. So the next big job is to separate it all. So as this hot stream leaves the reactor, it first goes back through those heat exchangers we talked about to warm up the new feed coming in. Then, it heads to some product condensers to cool down even more. And a really critical step happens right here. Wash water is shot directly into the stream. Why? Because the sulfur and nitrogen we removed have turned into new things, like ammonium salts, and as they cool, they can solidify and clog up the pipes. The wash water just dissolves them, basically keeping the unit's arteries clean. So after it's cooled, the whole mix flows into this big vessel called, you guessed it, the separator. And inside, it's just simple gravity doing the work. The lightest stuff, which is mostly the unreacted hydrogen gas, floats to the top. The heaviest stuff, the sour water that's now full of all those dissolved salts, sinks to the bottom. And right there, floating in the middle, is our prize, the purified liquid diesel.
Now that hydrogen gas at the top of the separator, it is way too valuable to just throw away, so the whole system is designed to recycle it. But there's a catch. It's now contaminated with hydrogen sulfide. That's a pretty toxic gas that was made from the sulfur we removed. So to clean it, the gas gets sent over to the recycle gas scrubber. And the slide's analogy is perfect. It's basically a laundry machine for gas.
This scrubber itself is this clever two-stage cleaner. In the first section, the dirty gas bubbles up through a liquid called amine. And this stuff is specifically designed to just grab onto and absorb that toxic hydrogen sulfide. Then, in the second section, the gas gets a final rinse with water to wash off any leftover amine. What comes out the top is clean, purified hydrogen, ready to go back to work.
This clean, recycled hydrogen now goes to these enormous compressors. Their whole job is to squeeze that gas and bring it all the way back up to the system's high operating pressure. It then gets mixed with a little bit of fresh makeup hydrogen to replace what was used up in the reactor and gets sent right back to the beginning of the process to treat new fuel. And with that, the hydrogen loop is complete.
Okay, so the hydrogen is being recycled, the sour water is being sent off for treatment, and we're left with that liquid diesel from the separator. Our fuels journey is almost over, but there are just a couple of finishing touches. It needs to be truly stable and ready for use. The liquid diesel is sent to one last tower, the stripper column. Inside, hot steam is bubbled up from the bottom. This steam literally strips out any tiny, lingering traces of dissolved hydrogen sulfide or other light gases that might be left. Getting rid of these last little bits makes sure the final product is stable and meets all the final safety specs. And this, right here, brings our journey to its final step. The hot, stable diesel from the bottom of the stripper is cooled down one last time. Then, just for a final purity check, it goes through a product Coalescer. It works on the exact same principle as the one from the very beginning, just to get rid of the absolute last droplets of water. From here, it's off to a storage tank as a finished, clean, stable fuel ready for the world.
So there you have it. From a simple water separator through a fiery exothermic reactor and out of a final steam stripper, we've followed the entire incredible journey of a single drop of diesel. This complex tech is really a hidden backbone of our modern world. But as we start looking towards new fuels and different kinds of energy, you have to ask the question, how will these amazing feats of engineering need to adapt and evolve for the future?